In order to understand this video, we need to look at the two faces of the IPCC, that's the UN Intergovernmental Panel on Climate Change. On one side, the data side, we have one set of conditions, that's based on science. On the other side, we have the political spin and tales of doom. But the differences are even exposed within our own documentation. So here we have the latest AR6 report and table 12 from it, and that table determines where historically we have found any difference with extreme weather between the history and natural history and man-made climate change. And the results are interesting. Just look at them. So this first column here, where it's white, is where they've not been able to find any signature of man-made climate change with the historic weather, and we're talking about extreme weather events here. So where it's white, no signal from so far in all the past of any change. Not even since 1850 can they detect any signature of mankind. Where it's coloured, they claim there is a signature. So let's go into the white ones first, and here is the list where the UN themselves, IPCC, find no signature of man-made climate change with extreme weather. So no trace from mankind historically with frost, mean precipitation, that's rainfall, river floods, heavy rainfall, that's heavy precipitation, pluvial floods, that's urban floods in cities, etc., landslides, aridity, that's very dry air, hydrological droughts, agricultural and ecological drought, fire weather, that's conditions for forest fires, wind speed, severe windstorms, tropical cyclones, that's hurricanes, etc., sand and dust storms, snow, glacier and ice sheets, heavy snowfall and ice storm, hail, snow avalanche, coastal sea flood, coastal erosion, marine heat waves, and ocean acidity, air pollution, and last of all, weather radiation at the surface. So, with all of those, there is no evidence whatsoever to date of mankind having influenced on all those characteristics with the climate. But what do they claim we have interfered with? Now let's take a look at that. So they claim there are differences in the heat and cold section, I'll go into detail soon, snow and ice section, and open ocean section. Let's take a look at the actual list where the differences are. So this is where they found evidence in the historic record of mankind interfering with it. Of course, any change has to be down to mankind. They found it in mean air temperature, extreme heat, cold spell, permafrost. So far, all those are related to temperature, the permafrost melting, etc. there. Lake, river and sea ice, not ocean, but lake, river and sea ice, mean ocean temperature, ocean salinity and dissolved oxygen. Now, the key here is that all of those are related to one thing, changes in temperature. So the entire basis of the alarm is not all the other things for extreme weather, but just extreme temperatures causing one or other effects. That is it. So what we're going to do in this video now is to look at temperature and maybe do it in a different way to the way you've seen it before. So that's the end of the prelude. Now for the video. Oceans and seas cover 71% of planet Earth. It is indeed a blue planet. At times, clouds cover 95% of the Earth. At other times, only 5%. And according to NASA, the norm is about 63% of the Earth. Our atmosphere is just a thin wrap around the planet. That atmosphere contains only 1,000th the amount of heat of the oceans and 1/50th of the amount of CO2 of the oceans. It is not the atmosphere controlling the oceans, it is very much the oceans and clouds controlling the atmosphere. We all know this, but now imagine the full extent of the oceans, this huge more than 2/3 of the area of Earth being covered with water that's highly absorbent to that heat coming from the sun, that shortwave radiation. So it's the radiation from the sun that heats the oceans, and it heats it down to about 100 meters as far as light penetrates. It is not the atmosphere heating the oceans. It's the oceans heating the atmosphere. So given that the entire alarmism industry depends upon temperature, we're going to take a look at just how temperature is actually measured and how reliable those measurements really are. Temperature is measured by taking the maximum and the minimum for each day and then adding the max and min together to divide by 2 to give you the average. This is a very crude measure and it has a number of problems, and I'll explain some of them now. The max temperature can be interfered with in a matter of seconds, such as a truck passing or a plane taking off, and this sort of interference can give you maybe 60 seconds of maximum temperature, and that'll be recorded and totally distort the average for the day. But there is another problem, and it's a big problem, no matter where the actual sensor is located. You simply can't put a thermometer in the air to measure the temperature. And the reason is the thermometer itself absorbs radiation from the sun. And therefore, you're not reading the temperature of the atmosphere, but you're reading the temperature of the actual thermometer glass itself. The best way to explain this is just look at how hot a car bonnet can actually get. Sometimes in hot climates, you can fry an egg on them. So in order to try to measure the temperature of the actual air, we put the thermometer inside a screen called a Stevenson screen. And this is one here. It's a louvered ventilated box. And the key to all this is ventilation, because unless air is passing through it, it doesn't measure the correct temperature. It actually would overread. If you just had a box without ventilation, the inside of the box would get hotter and hotter and hotter, and that would give a maximum temperature reading that was too high. And to provide sufficient ventilation, a Stevenson screen needs 1 meter a second of air passing through it. And to do that, because it's quite near the ground, it's about 1.2 meters from the ground, to do that you need round about 10 meters a second of air at 10 meters high. So at about 35 feet high, you need 22.5 miles an hour of wind. That's the sort of speed of wind you need to give you enough through that box to not overread the temperature. And of course, on hot summer days, we have a high over the UK, or anywhere else for that matter, and we often get hardly any wind at all. So there's a tendency on hot, still high-pressure days for these thermometers to overread. And so here we have two incredibly poorly sighted Stevenson screens so near to buildings. It can be trees or anything, and the shadow of a building or trees or any other obstruction, it's quite a distance it has to be before it doesn't interfere with the ventilation on the Stevenson screen. It can be between 4 times the height and 12 times the height of the building that you have a wind shadow downwind of that building. But so far we've only looked at a couple of the effects that can alter greatly actually the maximum temperature recorded. But actually more important is the minimum temperature. So now let's look at what factors, just some of the factors, that can affect the minimum temperature recorded. Minimum temperatures occur during the night time. And what really matters here is what is surrounding that temperature gauge, what is surrounding that Stevenson screen. And here you have tarmac, buildings, all sorts of things. In fact, cities themselves as a whole are much warmer than the outside rural areas. Therefore, the urban heat island effect, and that's what it's called, really matters as regards minimum temperatures. But over the last 150 years, urbanization has grown and grown right throughout the world. And with it, it has overtaken the temperature gauges. So temperature gauges that long time ago used to be out in the fields are now in urban heat islands. Some studies show in Europe, the Connellys did one, where 75% of the gauges they looked at now have the urban heat island effect. So what is the effect of this? Well, the effect is to keep it warm at night. So it lifts the minimum temperature. And by lifting the minimum temperature, you've increased the average temperature. So therefore it's possible to have no hotter weather at all and still have an increasing average temperature, simply because of the urban heat island effect. But it even gets worse than that. In America, over the last number of decades, the actual maximum temperatures have been decreasing, but the actual average temperature has been increasing. And the reason is because purely the minimum temperature has been rising. So let's take a simple example. Imagine that the hottest temperature, the maximum, has decreased by 1 degree C. But the minimum temperature overnight increased by 2 degrees C. The average temperature, therefore, ends up at rising by 1 degree C. But the hotter temperature decreasing whilst the average temperature increased. So it's warmer, yes, but it's not hotter. The range between the highest temperature, the maximum, and the minimum temperature is less. It's less extreme. So in other words, we're showing increasing average temperatures and less extreme weather. But climate records aren't based on a day or even a year. But in order to calculate the year's average temperature, they take all the daily averages and simply average those. So now let's look at what happens when you have a milder winter. Well, of course, with a mild winter, the average minimum has gone up, and therefore the average temperature's gone up, even though we had reducing maximum temperatures. It's just like rainfall. We've actually increased rainfall average since 1850, but at the same time, we've reduced the extremes. So we don't get the big droughts of the 1800s, nor do we get the big floods of the 1800s. The range has become less, and it's similar with temperature. So I will now stop imagining these scenarios, and we'll actually look at the real world. And we'll start with the UK and the British Met Office. Just how good are their Met stations? There was a Freedom of Information request made to the Met Office by the Daily Sceptic, and I'll read their report. Under the Freedom of Information request, the Daily Sceptic has obtained a full list of the Met Office's UK weather stations, along with individual class ratings defined by the World Meteorological Office. These CMIO ratings range from pristine class 1 and near pristine class 2 to anything goes or junk class 5. The CMIO ratings penalise sites that are near any artificial heat sources, such as buildings and concrete surfaces. According to the WMO, a Class 5 site is one where nearby obstacles create an inappropriate environment for a meteorological measurement that is intended to be representative of a wide area. Even the Met Office refers to sites next to buildings and vegetation as undesirable. It seems Class 5 sites can be placed anywhere. They come with a WMO warning of additional estimated uncertainties added by sighting of up to 5 degrees C. Class 4, uncertainties up to 2 degrees C, whilst Class 3 states 1 degree C, and only 13.7% or 52 of the Met Office temperature and humidity stations come with no such uncertainty warnings attached. This is remarkable. So let's look at those results for the British Met Office. Now keep in mind at this point that the entire increase in average temperature claimed since 1850 is in the order of 1.2, 1.3 degrees. Let's give it as 1.3 degrees. Well, look at the Class 5 stations, the number of those, around almost 30% of them. That's within 5 degrees. So it could even be cooling and we wouldn't know it. We have no idea what the temperature is from those. Class 4, that's within 2 degrees, again greater than the entire range of the increase since 1850. These are junk stations. Class 3, the yellow one there, they're within 1 degree. Again, with an accuracy of just 1 degree, and you're only measuring 1.3, it could be somewhere between, let's say, 0.8 of a degree, or adding half to it, it could be 1.8 degrees. You can't use it to measure something to that accuracy. So, that's also out. Not quite considered full junk, but very, very suspicious. And what are we left with? Well, we are left with 13.7%. That's the total of Class 1 and Class 2 stations. Just 13.7% of the Wet Office weather stations are considered pristine enough to be rated Class 1 or Class 2. But let's actually look at that a little bit further and look at what the Met Office claim when they're recording record temperatures. And we already know the difficulties of getting that maximum temperature when there's a high over Britain and there's very little wind. So let's just take a look at the claims. So this is what the Daily Sceptic, who were responsible for the Freedom of Information request, wrote. Using these figures with a precision to 1/100th of a degree centigrade, 1/100th of a degree centigrade, I repeat, the Met Office declared that 2023 was the second hottest in the UK, coming in just 6/100ths of a degree C lower than the all-time record. Cue, of course, all the we're getting headlines in the mainstream media. In 2022, the Met Office said that 5 sites in the UK on July the 19th went past 40 degrees centigrade with a record of 40.3 at RAF Coningsby. That, by the way, was a 10-minute record after 3 tornado jets had landed and taken off. Kew Gardens is termed a Class 2 site, although it's very close to one of the largest tropical greenhouses in the world. St James's Park and Northolt Airport are Class 5 sites. They're total junk. Heathrow is a Class 4, whilst Conaby is a Class 3. At the time, the Met Office declared that the record set a milestone in climate history. A national record was also set on July the 18th at Hawarden Airport in Wales. That's a Class 4. And on July the 19th at Charlton Hall in Scotland, Class 4. The commonality here is airports. But I'll proceed to the final conclusion of the Daily Sceptic on this Freedom of Information request. Here it is. Nearly 1 in 3, that's 29.2% of UK Met Office temperature measurement stations have an internationally defined margin of error of up to 5 degrees centigrade. Another 48.7% of the total 380 stations could produce errors of up to 2 degrees centigrade, meaning nearly 8 out of 10 stations, that's 77.9%, are producing junk or near junk readings of surface air temperatures. Arguably no scientific basis should these figures be used for the Met Office's constant promotion of the collectivist net zero project. Nevertheless, the state-funded operation frequently uses them to report and often catastrophize rises in temperature of as little as 1/100th of 1 degree centigrade. I'll now move on to how the Met Office defend themselves on this, and the next bit is taken from their website. World Meteorological Office sighting classifications were designed with reference to a wide range of global environments, and higher classes can be difficult to achieve in a more densely populated and high-latitude UK. Well, that's absolutely true. This is my comment now. That's absolutely true. In other words, we're a pretty densely populated place, not like some deserts, etc., and therefore it is difficult, no doubt about that. That doesn't change the fact it's giving bad readings. I'll continue now. For example, our criteria for a Class 1 rating for temperatures suits wide open flat areas with little or no human influence land use and high amounts of continuous sunshine reaching the screen all year round. However, these conditions are relatively rare in the UK. Mid and high latitude sites will additionally receive more shading from low and sun angles than some other stations globally, so shading will most commonly result in a higher CMIO classification. Most Stevenson screens in the UK are Class 3 and 4 for temperature as a result, but continue to produce valid high-quality data. Hold on. So they're class 3 or 4. That's 3, is within 1 degree, which is meaningless for what they're claiming, and class 4 is total junk within 2 degrees, and they're claiming that they continue. That's just an assertion. They're just asserting it still produces valid high-quality data. They don't give any reason for that. So they accept the classification, they accept the accuracy, and then they just state the blindingly ridiculous. I'll continue reading. The World Meteorological Office classification simply informs the data user of the geographical scale of a site's representativity of the surrounding environment. Well, that's what we're about. That's what it's all about. The smaller the siting class, the higher the representation of the measurement for a wide area. Well, that's true. If you want to measure atmospheric temperatures, you need a wide area. You don't need it, crammed on alongside a runway on an airport. That's true. It should be noted that World Meteorological Office Class 5 is not the same as Met Office Unsatisfactory Inspection Assessment, which ultimately determines the ongoing use of the site. In other words, even though we're a class 5, that's within 5 degrees. Within 5 degrees, if we say it's okay, then it's okay. I'll go on. We use the Met Office grading system, that's our own little thing now, to determine record verification because it has historical relevance, covering a wide range of long-standing criteria at UK observation sites, the equipment and the exposure in a holistic manner, and has a clear meaning to what is acceptable or not. It tells us how much confidence we have in the data and permits comparisons. It's holistic. Oh, I see. We've now gone into a world where science and facts don't matter. We seem to have to take an holistic approach so that we can look at preserving all the careers and everything that depend on this net zero madness. We have to consider all the wide factors when we read a temperature and we report how extreme it is and how bad it is. Because, let's face it, the Met Office used to be a small organisation in years gone by, but today it's a pretty massive one. And that has to be taken into account when you're reporting temperature readings. Whilst they're trying to preserve the historic long-term record by using class 3, 4 and 5 stations, they've got to understand that those stations have been compromised over time. For example, an airport has grown tremendously since 1950. For example, temperature gauges near buildings have been overtaken by more urbanisation. You really can't use this data, but they don't face up to that. The Central England temperature record is the longest temperature record in the world. It dates back to the 1600s, and up until recently has been treated with respect, but no longer. This is about the sad demise of the Central England temperature record because of interference by the Met Office. Here, a chap called Clive Best reports in 2017 on the Central England temperature record. There has been no change in UK average temperatures in summer or in spring for the last 367 years. The two hottest summers were 1826 at 17.6 C and 1976 at 17.8 C. I remember 1976 as the perfect summer, with 2 months of continuous sunshine causing a severe drought. The two coldest winters were 1740 at minus 0.73 C and 1963 at minus 0.07 C. 1963 was the perfect time to be a small child, aged 10, sledging every weekend. These extremes have not been exceeded for the last 40 years. Writer Paul Homewood last year discovered considerable tampering in 2022 with the recent Central England temperature record. He initially found that in version 1, the summer of 95, had been 1/10 of a degree C warmer than in 2018, but in version 2, the 2 years swapped places, with 1995 cooled by 7/100 of a degree C, 7/100, and 2018 warmed by 0.13 degrees C. Alerted to these changes, Homewood then analysed the full record from version 1 to version 2, and the graph below shows what he found. So by taking one graph away from the other, we could find the adjustments. So Homewood went on to say, as can be seen, the adjustments up to 1970 are small, with the ups and downs offsetting each other. Homewood then found that the years from 1970 to 2003 had been cooled markedly, followed by significant rises to 2022. Homewood concludes that unfortunately it is part of a much wider tampering with temperature globally, and that tampering is always one way, cooling the past and heating the present. Given that we now know that the Met Office has been using Class 4 statistics for 2/3 of its database since 2006, the recent higher adjustments would seem to call for clarifying explanations from a state-funded Met Office. I endorse that. I mean, this is absolutely ridiculous, and it just shows you how they have to fit an agenda. So now they can show you the modified graph that fits in with their political narrative. But we're not going to leave our cousins across the Atlantic alone. I mean, let's face it, they deserve examination as much as our UK Met Office. So here we take a look at what's been happening in America and the state of their climate stations. The USA has the widest, most complete set of temperature records in the world. This graph, where it's coloured grey, the darker the grey, the greater the intensity of the temperature records, is such that it just dominates the world record. And you can see the other grey parts in Europe there, the lighter grey, and down in Australia. That is it for the long-term records. The rest of the world has next to nothing. So it is an important factor. Now, I could go into great scientific detail here based on this report here. Anthony Watts did a report back in 2009, which showed the scandalous state of the USA weather stations. But he found recently, in 2022, it was even worse. And I could go into all the detail, as I said, but what I'm going to do is simply show you some of the standard stations that they rate and use for temperature records. And I'll leave it up to you, with the knowledge you now have gained from this video, to judge the quality of the data. But that USA story gets even worse, because they've turned weather stations into ghost stations. Stations that do not exist, but still report temperature records, and not just a few, but on a grand scale. The USA temperature system reached a maximum of 1,218 stations in 1957. But after 1990, the number of active stations began declining due to aging equipment and personal retirements. NOAA still records data from these ghost stations by taking the temperature readings from surrounding stations, recording the average for the ghost station, followed by an E for an estimate. NOAA fabricates temperature data for more than 30% of the 1,218 reporting stations that no longer exist. They are physically gone, but still report data, like magic. Temperature data from compromised bias stations, temperatures reported from non-existing ghost locations, temperature data adjusted or homogenized to fit a narrative, and independent sources of data from the surface, satellites and weather balloons that report much less warming than recorded at compromised adjusted, now evidently non-existent stations, leads one to question why anyone should trust the official government reports on rapidly rising, regularly recorded setting temperatures. Such fake data wouldn't stand up to scrutiny in a court of law. It surely shouldn't be relied upon to drive public policies limiting the freedom of billions of people in their personal and economic lives. And there's the source. It's the Heartland Institute. But now for some good news. The Knights are going to rescue us. There's a rescue for all this corrupted data coming. And it's called the US Standard Reference Network. It's about 120 stations spread strategically across the USA. They're absolutely perfect stations. They've even got triple redundancy built into them. They're perfectly located and are really set up well. They were set up in 2005, and so already we've got 19 years of data. Okay, not very long term. But what's been happening to that data? Where is it? Well, let's look at it, because you can go on our website, link provided in the description below this video, and you can investigate it yourself. So here are some of the graphs from it. Well, here is the first graph from it, and I've chosen the average temperature is on a monthly basis and for all the records since 2005. So what does that show us? Well, oh dear, there's some peaks way back there early on. So we're not really showing very much in the way of changing rising temperature here, are we? I know, let's try the maximum temperatures. And drat, it was much higher in the past. So maximum temperatures were earlier than now. Not going with the narrative. Well, we'll look at the minimum then. Well, frankly, I can't see anything significant in this particular graph. I mean, it's pretty well level. What you're not seeing here actually is a big rise. In fact, the whole of the standard reference network goes against the agenda on its data so far, and its 19 years of data goes against the agenda of global warming. So what do? They ignore it. Now, even with land temperatures, the gauges we have over the whole Earth historically are minimal. We have a lot in America, we have a reasonable amount in Europe, hardly any in Africa, hardly any in the Southern Hemisphere, none in the Antarctic going that far back as we need to go, etc. And so the actual temperature measurement data is very scarce on land. But 71%, as I've already stated, of the Earth is sea, is ocean. How do we measure that? How historically have we measured that? So let's look at some of the issues in historical sea temperature measurement. Well, the fact is that historically, the only way we could measure temperature in the sea was for boats to measure it. But they weren't on a mission of science, most of them. They were just ad hoc on routes from A to B. And they had two methods of measuring. Well, the traditional method was to chuck a bucket overboard on a rope and haul it in and then measure the temperature. And the other method that became available when steam became available, when we had engines, was ships need to suck in the sea to cool the engines. They suck in the seawater, go through a heat exchanger to cool the fresh water that's cooling the engine. And so they had temperature gauges on the intakes of the boats. So there are two distinct types of measurement. Both of these methods have their issues, serious issues. The bucket method, well, in rough weather, they didn't bother. The deckhand didn't bother very often anyway. And anyway, who's measuring the temperature? It really was rough and ready, and the readings are pretty well all over the place. The engine intake method is better. Yes, it's better, and millions of those have been taken over the years. But the purpose of the thermometer there is simply to warn of temperatures which could lead to engine failure, and they often only read to within a couple of degrees. So they weren't really accurate in the sense we're looking at. The fact is that there was no scientific approach to that data. I mean, the least they could have done was separate off the engine intake data from the bucket data, but they didn't even do that. They mixed it up. The Connollys from Ireland did actually separate the data, and the engine data seemed better, and it did show a 1930s warm period, whereas just the bucket data was all over the place. It didn't do anything. But some 8 years ago, in 2015, all that changed with the first deployment of the first Argo buoy. These buoys, and I'm going to show you how they work now with a clip from the Australian Meteorological Organisation, really do measure sea temperatures. They measure them down to 2,000 metres, although new ones are even going deeper. There are now almost 4,000 of these buoys deployed around the world's oceans. And so for the very first time, we are measuring sea temperatures, and we're measuring them on the profile as well, down to 2,000 metres in general, and in the future down deeper. And this is important work, and I very much support it, because we are really collecting reasonably good data. So let's look at how these Argo buoys work. graph shows the temperature from the buoys, but only from 2015. You have to ignore the previous temperatures, which were taken by totally different methods. And of course, we only had very few buoys in 2015. So as we've increased the buoyage right throughout the world, quite a lot actually, we're getting a totally different set of measurements in different places. So this is just early work, but it is the work of the future for monitoring water temperature. 2023 was a very warm year in the world, but that warmth came mainly from the oceans. The El Nino here is a huge upswelling in the Pacific Ocean covering a huge area where temperatures can really rise, and this year it was over 2 degrees centigrade above its base, if you like. So that heated the atmosphere enormously, and that is responsible for putting a lot more moisture into the air, and basically what goes up comes down, and you tend to get more rainfall and all sorts of effects. It's a worldwide event. The opposite of that is a cold upswelling, and that's called the La Nina, and again has a huge effect on the world temperatures. It warms and cools the planet. On balance, the El Nino and La Nina tend to warm the planet. This particular graph has every El Nino on it since 1950, and you can see how they depart from the normal temperature far more, give you far more heat than the La Nina, which cools. And so some years you get very big El Ninos, such as we've just had, and they can add a lot to the planet. As you can see, 2 degrees over vast areas of the Pacific, a significant factor in governing world temperature. But these events aren't alone. Let's look at the North Atlantic. Now turning our attention to the Atlantic, what's known as the Atlantic multidecadal oscillation lasts for about 35 years of warm and about 35 years of cool, and the range is about 0.5 C, 0.5 centigrade, and that's may not seem much, but this vast area warms up, by 0.5 degree centigrade or so, and that is a lot when you're looking at a total atmospheric increase of just 1.2 over 150 years. Now, the cycles aren't quite exact, but at the moment we are still in one of these warm phases, but it is coming to an end. The moving line is what we call the AMO index, and the actual measurements are there in the sharp peaks both ways, so you can see the cycles and how long they last. Now look here in 1940. Now we know it cooled from that period, so it started to cool into the 60s until it got to the 70s and recovered again around about 1980 when it started to warm again. This was the Ice Age coming scare that we had, and we are still in the warm phase that began in 1995. So that is now about 29 years old, and so it is coming to an end over the next few years. But now let's go back to the Pacific and look to see if there's anything similar to this AMO in the Pacific. Well, shiver my timbers. There is a similar one in the Pacific, which lasts for 25 or 30 years or so. And again, similar in range, well, actually worse. It can go up about 0.5 of a degree C and down that much. So this is a much bigger area than the Atlantic one. The El Nino, of course, is much shorter duration and actually larger. But consider the El Nino and La Nina to sit on top of this base. That's the way to see it. So you've got a 20 to 30 year base of temperature swings, and your El Ninos or La Ninas sit on top of that. Continual warming and cooling. So let's look at the pattern here. Let's look at the pattern we get from the Pacific decadal oscillation. And all that means, by the way, is the decadal just meaning they last for decades, these things. They're not like your El Ninos, which are short term. So this warming shows warmth in the 1930s, just as we had in America with the Dust Bowl. We had the hot 1930s. And then we cooled and we cooled until about 1970s and then started to recover about 1980. In fact, 79 is the starting point for almost every graph on ice cover in the Arctic and so on. And it's for this reason, because that period here is where we started to warm. We had a warm period again. But then as we pass 2000, things level out on this, and then they drop again and come up. Well, having done the Atlantic oscillation and the Pacific oscillation, it'd be pretty bad to leave out the Indian Ocean one. This is a much more sporadic event and also not on the same scale as the Atlantic and the Pacific ones. This sort of oscillates between having the cold there in the east, and whilst you've got that, you've got the warm in the west part of the Indian Ocean against Africa there, and that swaps around to the other way. Now, when you've got the warm there, so we'll go back to the warm, when you've got the warm against East Africa there, you get really heavy rainfall. In the 1960s, I was working in the Saudi Arabian desert and living in a tent in the middle of that desert, only to be flooded out by intense rainfall, where a river formed within minutes out of nowhere, swept through our area and flooded our tents. So I know what it's like to have really supremely heavy rainfall in the Middle East, a bit like what's happened in Dubai. What helps that tremendously, of course, is this dipole being warm against Africa there in the Middle East. And of course, when the dipole has the warm over Indonesia and over there to the east of this, then you get increased monsoons. You get floods and all these sorts of stories we see in the news about flooding in that area. This adds to it. This graphic from the Woodhull Oceanographic Institution is very good at explaining this dipole. And as you can see, the cold water, look at the top diagram in the positive phase, and the cold water's up against Indonesia and so on, and that causes droughts. Whereas on the other side, you're getting heavy rainfall. Go to the bottom diagram and the droughts move over to Africa and away, and you get the heavy rains, the extra monsoons in the east there. So these oceanic events, in all their phases, in all their oceans, are a major influence on our climate, and we do not fully understand how any of them are controlled or formed. This is a chart from NASA covering the Indian Ocean dipole. And just look at that positive phase. That's when the heat's against Africa. And here, currently, we have it at record levels. And guess what? That's right, Dubai floods. And of course, this is a weather event, not a climate event. It's a weather event. And the alarmists make the most of every weather event. And every time they do that, to any individual weather event, unless they show a pattern over many, many decades of the event changing, that's climate, they do not understand even what climate is. I originally intended in this video to carry on to discuss ocean currents, but there just simply isn't time to fit it in to this pretty long video already. I hope you've enjoyed the video. Basically, I've tried to demonstrate to you that even the raw data being collected on land is very, very poor. Obviously, the satellite data is far better and far more global. But the problem is, for the alarmists, the satellite data doesn't agree with their agenda. We are living in a world of an agenda, not science. And I'm doing all I can in the UK to fight that madness. Well, if you made it this far in the video, I'd like to thank you for watching it. I hope you found it informative. Obviously, I'd like to carry on and discuss ocean currents, but we'll have to leave that for another day. In the meantime, again, thank you for watching. Meet you in the future on even more videos.